Okay, so today we're going to be learning about scientific notation. Scientific notation takes a really, really big number or a really, really small number and makes it easier to write. So a lot of times you actually use scientific notation in science because you'll be dealing with large weights, small weights, things like that. But it's always good to know. So we have the scientific notation follows a format as a digit in front of it, one digit in front of the decimal, followed by other significant digits. A significant digit is 1 or greater, so 1 through 9. But let's say and 0 is not significant. So it would be if it follows by an important digit. So let's say I have 1, 0, 9. 0 in this case is significant because it's followed by a 9. If I had 0.1, 0, 0, you would not need to write those zeros because those aren't significant. And so that's the first part of scientific notation. So you have blank, period, decimal, blank, blank, times 10 to an exponent. The exponent is how many times you move the decimal, and I'll show you. So we're going to start off with this example. So we have this large number. So I'm going to take the significant digits because all the rest of them are zeros. So the significant digits are 2, 5, 3. So I only need a one digit in front of the decimal. So it's going to be a 2.53 times, times 10 to the exponent of how many times I have to move my decimal. So my decimal's in the back. And so I need to move it to in between the 2 and a 5. So I'm going to go 1, 2, 3. See, I counted 3 zeros. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I had to move the decimal 13 times to get in between the 2 and the 5. And that is scientific notation. So let me make this a little bit clearer. So my scientific notation for example 1 is 2.53 times 10 to the 13th power. All right, so I just did example 1. Go try and do example 2. So pause the video and do example 3. Excuse me. Please pause the video and try example 3. Okay, so example 3. So my significant digits are 3, 7, 4, 9. So my numbers will be 3.749 times 10 to the exponent, which I don't know. But I need to get my decimal in between the 3 and the 7. So my decimal is in the very back because it's a whole number. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So I moved it 9 times. So since I moved it 9 times, my exponent will be 9. That's how you change a really, really big number to scientific notation. Now what we're going to do is we're going to take a really, really small number and change it to scientific notation. So we're going to do example 2. So again, I have 2, 0, 3. In this case, the 0 is significant because it's followed by a 3. So my scientific notation will start off as 2.03 times 10 to the negative exponent. The reason why it's negative is because I'm changing a decimal to a scientific notation. When you do that, you have to use a negative. So you see on the first example, I move my decimal towards the left. When you move towards the left, that means you have a positive exponent. In this case, for example 2, I'm taking my decimal and I'm moving it towards the right. That means it's negative. So we're going to go 1, 2. So I'm just counting the zeros. 1, 2, 3, 4, 5, 6, 7. So there's 7 zeros in front of the 2, but I also have to move it behind the 2, so I have to count the 2. So that's 8. So it'd be negative 8. And you're thinking, well, right to the right is always positive. And yes, that is a true statement. But you'll realize why your exponent is negative when we have to change the scientific notation back to standard notation. Okay, and you'll see that further. But in the meantime, do the example number 4, pause the video, try that out by yourself, and then I'll do it for you. Okay, so my significant digits will be 5269. So that means my number will be 5.269 times 10 to the negative exponent. So I got to get my decimal in between the 5 and the 2. So I have 1, 2, 3, 4, 5 digits in front. So that'd be times 10 to the negative 5th power. Okay. So now we're going to go down. Whoops. What's it doing? And go down to example 7. So this is already in scientific notation, and we're going to change it back to standard notation. Standard notation is just what you normally see, your standardly. So this number is 7.921 times 10 to the 8th power. That 8 means I need to move the decimal 8 times. Since it's the positive 8, I'm going to move the decimal to the right for positive. So I'm going to take my number, 7.921, and I'm going to grab this decimal right here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And in all these blank spots, you put a 0. So your number will be put some decimals so I can read this. Will be 792,100,000. Yes. So, but see, that's the reason why scientific notation is easier, because it's easier to say. So that's example 7. Why don't you go and try example 9? Pause the video and try example 9 by yourself. Okay, so I'm going to take my numbers, 4.13. Since it says the exponent is 3, I'm going to take my decimal and move it 3 times. 1, 2, 3. So I get 4,130. Okay, now let's try example 8. So example 8, my digits are 8.2. Well, actually, I'm going to rewrite this. So it says 8.2, but to the negative 5th power. So I'm going to write 8.2 over here, because negative 5 means I have to go to the left 5 times. So I'm going to take this decimal and I'm going to move it to the left. So I can go 1, 2, 3, 4, 5. Put my decimal there. 1, 2, 3, 4. And that is your number for example 8. Why don't you pause the video and try example 10. Okay, so my significant digits are 5.2216. It says you need to move your decimal 9 times towards the left. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So decimals right here, and then you'll have 8 zeros in the front. Pretty crazy, right? But that's it. That's scientific notation and changing it to standard notation. If you still have a little bit difficulties on it, message me or look up a video in Khan Academy for scientific notation. They have a really good one. Thanks, guys.